Okay, how many moles of hydrogen cyanide are contained in 9 grams of HCN? Let's go at 9.00 grams of HCN over 1 grams per mole. 1 mole of this stuff has a mass of 27.03. Hey, look, 927.03, that looks like it's about 1/3, right? So that's going to be 0.33. If you do the math, it's like 0.3329 or something like that. So 0.333 moles. That's going to be letter A. How many molecules are in 2.0 times 10 to the negative 2 moles of carbon tetrachloride? So 2.0 times 10 to the negative 2. 1, 2, so that's going to be 0.02 moles of whatever that is, carbon tetrachloride. 1 mole of this stuff has, we don't need molar mass, you guys. We know that 1 mole is 6.02 times 10 to the 23rd molecules. Okay. So 0.02 times okay 1.204 times 10 to the 22. There you have it, letter D. In the Lewis structure for ammonia, NH3, how many lone pairs of electrons does the nitrogen atom have? Let's draw the nitrogen atom. 1, 2, 3, 4, 5 valence electrons. Here are your hydrogen-nitrogen bonds. Those are single bonds. That's your lone pair. Okay, so that's going to be 1. Letter B. Next, number 14. Which of the following describes the bonds in a molecule of ethyne C2H2? C2H2. We know we have to put those H's there. That leaves 1, 2, 3. I'm not drawing them in, but 3 dots here, right, on each one. So those 3 dots form a triple bond. There you have it, C2H2. Okay, here's what it would look like had I drawn those dots in, right? Okay, so these 3 right here, you got to form a triple bond. Total number of dots drawn in the Lewis structure for nitrogen N2 is, okay, so look, N2 we know we got to draw like this. Here, let's do it like this. Okay, and these things form, and then that one right there will form one right there. Okay, it'll form another one here. How do we do that before we did something like that, right? All right, so look here, we can count. So it looks like this, right? We can count each one of these lines as 2 dots, right? So if we were thinking about it like that, then it would be a total of 10 dots, because we got 2, 4, 6, 8, 10. Now what I will do is this. I'll say here in parentheses, I'll say something like each bond counts as 2 dots, right? Each bond counts as 2 dots, something like that. Okay, to clarify a little bit more for you. All right, this right here is a typo. Carbon monoxide looks like this, guys. That's a typo. Okay, this should have been over here. Instead, that suggests there's a triple bond there. There's not. It's a double bond. Okay, so that's a typo. So I'll be on the lookout for that. All right, but remember, that's a single bond right there. That's a double bond, and that's a single bond. Okay, anytime you have these dots shared between the 2 atoms, that's a single bond, or if you got 2 of those pairs, that's a double bond or a triple bond. This suggests a triple bond. See, there's 1, 2, 3. That's incorrect. Carbon monoxide looks like that. So I'll be on the lookout for it. If something like that happens on the test, I will take it off. Okay, I can take it off the test after the fact. Don't worry. Okay, I will not count it if I see something like that. I'm going to proofread ahead of time and try to catch all of those. Which of these molecules is polar? Polar. So we've got strong, weak. Polar means strong, weak. Oops. Strong, weak, that don't cancel. right? That don't cancel. So there's that strong, weak, but those cancel. These two cancel. That's strong, weak, but so is that. That cancels. That's strong, strong. That's strong, strong. So that doesn't even qualify. Okay, so here's strong, weak, right? Here's strong, weak. And here's strong, weak. There's nothing down here that cancels. Okay, it's all going this way. It's all going towards nitrogen. So it's going to be letter B. Letter B. Which of the following is most polar? Okay, so again, polar means strong, weak. Strong, weak. Okay, weak, weak. Strong, strong. Weak, weak. So the only one that's left is strong, weak right here towards nitrogen. That one doesn't cancel either. Which of the following is paired incorrectly with the solid that it forms? Okay, bronze is a mixture of copper and nickel, so that does form a metallic solid. That's correct. Ionic solid means metal, non-metal. That's also correct. Molecular solid or covalent solid. Covalent solid. Okay. Covalent solid, I believe, is what we called it. Is H2O. That's correct. Network covalent. Okay, network covalent is only SiO2 / quartz. Quartz / silica. Okay, that's it. Or on the other side, diamond / graphite. Okay, those are the only network solids, network covalent solids that we're talking about here. So it's going to be letter D, P4O10. All right, letter D. Make sure you got that there. All right, number 20. An unknown solid has a melting point of 400 degrees C and conducts electricity. Okay, so there's two things here. Medium melting point. Medium melting point. It's not low, but it's also not high. And conducts electricity. That conducts electricity, conducts but high. High melting point. The highest melting point. Okay, conducts, but it's a high melting point. Non-conductive, and low melting point. I'm going to say MP for melting point. Diamond, high MP, but non-conductive, right? It's a non-metal. High melting point, but non-conductive. Okay, non-metals are not conductive. So the only thing left here, this is 400 degrees Celsius is about the melting point. It's a medium melting point, right? And it's also conductive. Okay, so medium melting point, yeah, 400 degrees C, 400 to 800. These salts get up to 1,000, right? 1,500, something like that. But metals tend to have, pure metals tend to have a lower melting point. Okay, they tend to have a lower melting point. Okay, so 400 degrees C is a good sort of area for a metal, and metals are conductive. Okay, so there you have it. Which of the five, if it was a salt now, if it was a salt, it would be conductive, but it would have a melting point of over 1,000 degrees C, 1,200, 1,500, something like that. Which of the following is expected for a sample of solid P4O10? Sample of P4O10. Well, it's a covalent compound, right? So it's not going to be malleable. It's not going to conduct electricity, and it's not going to be lustrous. Okay, it's going to have a low melting point. Okay, it's a covalent compound, non-metallic, right? Non-metallic. So it's not going to have the characteristics of metals. Okay, that's going to conclude this video. I will go ahead and make the third video.